Okay, now we have finished up with all the major flies that you're most likely to see at a crime scene. Now we are going to move on to the next order of insects that you will see, and these are the Coleoptera. Remember back to your very first introduction to all these different insects, and remember that the Coleoptera are the beetles. So, Coleoptera, beetles. Now this is the largest order of insecta out there. So this is represented by over 350,000 identified species, which is just nuts. So many of these species. It represents 40% of all known insect species and a good portion of all known animal species out there. So I know I talked about this at the beginning of class when we were first talking about arthropoda, when we were talking about the beetles themselves. So a good portion of organisms on Earth are actually beetles. Now, 2/3 of the world's beetles are found in 8 major families. So of all these huge number of beetles out there, they're mostly found in these families, and then we'll go over a few of the more forensically important families in a little bit. But if you're just outside looking at beetles, more than likely you're going to be finding these. So we're going to start out with the Curculionidae. So the Curculionidae are the weevils. The weevils are these adorable little beetle-y things. They're known by these long proboscis, or these long snouts that the antennae hang off of. So they're just super cute. They're in Curculionidae. Chrysomelidae, these are the leaf beetles. This is one of the more interesting leaf beetles. A lot of leaf beetles are just kind of boring and green because they're blending in with leaves, but this is one of those gold, neat ones, so leaf beetle. Staphylinidae, these are the rove beetles. Staphylinidae are characterized by these little tiny elytra right there. So remember that Coleoptera are represented by the elytra. So you can see the elytra on all of these beetles here. So remember, coleos means sheath, and that's that first pair of wings that are turned into the sheath. So in the Staphylinidae here, you've got this prothoracic region that is really elongate. Remember, there are no wings on the prothorax. The mesothoracic wings are super short, and they do have metathoracic wings just underneath there, but you can see most of their body. On most beetles, their elytra are covering both the last two segments of the thorax and the abdominal segment. Staphylinidae is a little bit different. So a lot of people confuse Staphylinidae with some of the other more primitive insects. Up next is Cerambicidae. This is these are the longhorn beetles, and they're named longhorn beetles because they have these big, long, very obvious antennae with interesting shapes and things on them. These tend to be wood-boring beetles, so they will feed on cellulose, on wood. Up next are the Carabidae. These are the ground beetles. These are sort of boring looking beetles that you find. They're black or brown for the most part. There is one really interesting bright greenish ground beetle. It's almost rainbow in the different colors it has, but for the most part they're black. So a lot of ground beetles out there. Scarabidae. Those who get interested in beetles tend to be interested in the scarab beetles. That's Scarabidae here. These are those generic, just beetle-looking beetles that you see out there. They're likely scarabs. This is one of those neat, bright gold beetles. You can find these in Central America, and they're just super, super shiny and really pretty. But scarab beetles run the gamut from super boring brown and black colors to just every color of the rainbow. Up next is the Tenebrionidae. These are the darkling beetles. So these darkling beetles right here, they're just normal plant feeders. They come in all shapes and sizes. And finally, the Buprestidae. These are the jewel beetles, or the metallic wood-boring beetles. Okay, so you've got these beetles that feed on wood, but they tend to be very, very bright in coloration. Notice that their format is a lot like the Cerambicidae here, other wood-boring beetles, a lot like this Tenebrionidae, but they tend to be very bright in coloration. So there are a lot of beetles out there, 350,000 known species, just over that. And really one of the reasons that we know so much about them is there are a lot of people who are super into beetles because they're just neat. And a lot of people enjoy looking at them and enjoy categorizing them. Also, because of those elytra, the beetles are able to move into a bunch of different habitats, which means there's a lot of niche partitioning, which means there's a lot of speciation. So we end up with a whole mess of species. And I can tell you right now that we haven't discovered all the beetles that are out there. People are constantly discovering new species. This is just going to go on for a very, very long time. So, general overview or general reminder of what these beetles are. So remember, the word Coleoptera literally means sheath-winged. So the adults are distinguished from all other insects by the presence of those hardened forewings, by those elytra. The elytra will cover and protect the membranous hindwings. So looking at the beetles, you are looking for that center midline right here that will tell you that these are elytra. Remember that there are several Hemiptera that look a lot like beetles, that have that sort of shiny sclerotized back, but they won't have that center midline there. Okay, so if you lift up these elytra, you will see these membranous hindwings. So this is what a ladybird beetle looks like when it is getting ready to take off, when it's getting ready to fly. So it'll lift up these elytra, these membranous hindwings will be underneath, they'll unfold and allow the insect to fly. Now, the diversity of Coleoptera just is remarkable. They can range in size from 0.25 millimeters, so even smaller than the tiniest fly that we looked at last or 2 or 3 times ago, all the way up to 150 millimeters, so 15 centimeters. So you get these huge, huge beetles, the size of your hand, all the way down to these teensy tiny, size of a grain of rice beetles, and everywhere in between. Most you will fall into the range of about 2 millimeters to 20 millimeters, though. So somewhere in that about 2 centimeter range at the height. So those extremes are, again, extreme. Most are sort of right in the center. Now, most commonly, we're going to see black and brown beetles. This is because they are often hiding. They often undergo crypsis, which means that they're hiding instead of trying to fight or run away from predators or whatever else they're doing. So those that need to blend in with their background are going to do that. They're going to blend in with the ground. So they're black or brown. Sometimes they'll blend in with the bark of trees, that sort of thing. Okay, so they're just unremarkable in coloration, but there's a huge number of bright colors in this order. So this is what most people recognize as beetles, are the really pretty, brightly colored ones. Now, the head is usually conspicuous in all beetle species, and almost all beetles have some sort of biting or chewing mouth part. So this is what a beetle head looks like up close. You've got your big old chewing mandibles right there. If you look here, you can see their mandibles. Can't see it on this little tiny guy. And here, this is the head of the ladybird beetle. You can see the head is sort of facing downwards, and it's got chewing mouth parts underneath there. So most of the time, they have these chewing mouth parts. Now, I have to be very careful when I talk about generalities of Coleoptera, though, simply because they are so diverse that the second I say all have chewing mouth parts, we're going to find one that doesn't. It's going to be piercing and sucking, or it's going to be rasping, or it's going to be something crazy. So you're going to hear me saying this a lot when I'm trying to generalize about Coleoptera, as most of them have this, at least that we know of right now. Now, the antennae vary quite a bit across Coleoptera. So we don't see the same sort of antennae like we do for Orthoptera or for Odonata. Right, so Odonata have those little sedate antennae. Orthoptera tend to have filamentous, the same with Blattaria or Blatodia, and with Brachycera and Nematosera, the suborders, we see aristate or plumose/filiform. So in Coleoptera, though, they're just all over the freaking map. So we see them long and filamentous to clubbed to plumose to geniculate to just everything. So really, it's hard to generalize the antennae in Coleoptera. They're just very, very diverse depending on how they've evolved. Now, the part of the thorax that is visible dorsally behind the head is the prothorax. So you got your head right here, you got your prothoracic region right there. So the prothorax is in front of that mesothorax where those wings are, and those wings go back and cover, so you can see the prothorax in beetles. Now, this section in beetles is specifically called the pronotum, So you will see that specific term quite a bit in beetle keys. The rest of the thorax is usually covered by the elytra. So you may need to look at the shape of the pronotum. You may need to look at the coloration of the pronotum if you are identifying beetles. And depending on the size, the shape, all that sort of thing, that can help you identify at least a family, if not a little bit further. Now, like a lot of these orders that we're looking at, beetles undergo holometabolous metamorphosis. Remember back to that. Now, the eggs are laid either singly or in clusters. Just like most holometabolous organisms, they tend to lay their eggs near or on a suitable food source for the larvae. Now, in beetles, that can be, anything. It can be anything from on or in the soil, on living or dead plant matter, on fabrics, underwater, on carrion. Every once in a while, beetles, we even lay their eggs on living animals. It just depends on their habitat. So the eggs are going to hatch into the first of several larval instars. The number of instars varies with the species, but they do tend to have a minimum of 3 larval instars. At least most of the known beetles have a minimum of 3 larval instars. So if I say, ask you on the quiz, what's the minimum number of instars that most larval beetles have? Your answer is 3. Yeah, just so you know. Okay, now, the larvae of most beetles have a distinct head capsule. They usually have simple eyes and they have chewing mouth parts. So what we see here, this is the ladybird beetle. These are what their eggs look like, and this is what the larvae look like. So they look significantly different from the adults because of course they do. But you can see that they've got this head capsule right here, and they don't have really big compound eyes that you can see. They do have simple eyes for the most part. Now, they will also have this 3 pairs of legs on the thoracic region. They just have those pro, meso, and metathoracic legs, just like the adults. So unlike the Diptera, which are legless, the Coleoptera have legs in the larval form. This is one of the ways to tell Coleoptera larvae from pretty much anything else. Distinct head capsule, 3 obvious pairs of thoracic legs and no other legs. So we see some other legs in, say, the Lepidoptera or things like that, but not the same. Okay. Now, most temperate species of Coleoptera only undergo 1 generation per year. So they're univoltine. So 1 generation per year. So they're pretty slow growers. There are species in warmer climates, though, that are multivoltine. They can undergo numerous generations per year. So it really just depends on the species and where they live. The adults will live anywhere from a few weeks to about a year or so, although there's a limited number of species that will live for several years. These species people tend to keep as pets, so there are quite a few beetles that you can buy as pets. And there's also this whole thing in certain places you can buy beetles where people have glued jewels to their elytra, and they've attached a little chain so you can wear this sort of living jewelry, which is pretty amazing. All right, so beetles are known to live within all terrestrial and freshwater habitats. So they have been able to exploit every habitat except saltwater. So we haven't seen them in saltwater yet. So that's not saying they won't be there or they're not there. We just haven't seen them. Now, this variation in habitat leads to variation in feeding behavior, as you might imagine. So there are beetles that feed on dead tissue, on living plants, on living animals, on other insects, or they're a combination of one or more of those sorts of things. So there are omnivores. Now, because of all of this crazy diversity, we see a whole bunch of either problems or benefits from beetles. So adults and larvae of just a few species will occasionally bite. So you can get bitten by a beetle. They do have chewing mouth parts, but most species just won't. They just won't bite you. Either they're too small, especially those little tiny beetles. There's no way they're going to be able to bite you. There's some that will just try to bite to get away. So the bigger the mandibles, the more likely it's going to hurt when it bites. But really, you're really safe picking up beetles and just, wandering around with them. More than likely, to defend themselves. Instead of, say, biting, they won't sting, but they might secrete chemicals. So there are a bunch of different species that have chemical compounds in their hemolymph, or they produce chemical compounds that they will use for defense. And these chemical compounds in humans can irritate the skin and the eyes of humans and animals, and they're very common defense mechanisms. In the species that have them, it's either the adults, the larvae, or both that can produce these irritating chemicals. And there's a few that are very, very common. One is the Spanish fly. So the Spanish fly is a maybe not so anymore, but sort of well-known aphrodisiac that is used in certain areas. It is a beetle instead of a fly. Looks like this. And it is used because it has a irritation substance in its hemolymph called cantharidin. So cantharidin, this is a chemical in the blood of the Spanish fly, which can irritate tissues. Now, the reason that it is used as an aphrodisiac is because if you eat the dried up bodies of this beetle, you will ingest this cantharidin, and this cantharidin will cause in men something we call priapism. So priapism is uncontrolled erection. So you know all those little blue pill advertisements that you see on TV that talk about if you have an erection that lasts for more than 4 hours, go to the doctor. Yeah, so that's what this causes. It's because of irritation of some very delicate vascular tissues in the penis. And so people are like, oh, it causes priapism. It's an aphrodisiac. If you don't know what it means to have to get that fixed, when you have the uncontrolled erection for 4 hours, when you go to the doctor, you have to go and they will take a large needle and remove the blood from those tissues. So don't do this. So Spanish fly is actually a beetle. It's used as an aphrodisiac because of the cantharidin. It's also a big problem with grazing animals because it is a plant feeder. So grazing animals can accidentally eat it, and it can cause poisoning, especially in horses. Now, probably the most dramatic defensive maneuver that we see in beetles is in the bombardier beetle. That's what we're looking at here. In this case, the bombardier beetle will produce an explosion of a hot, acrid liquid from the anal glands. And so what it does is it aims its posterior end at a potential predator or at a threat, and it'll shoot out this really hot, acrid liquid at it. So that's why we call it a bombardier beetle. Now, it can cause minimal damage in large animals. It's not pleasant, but it's not going to blind you or anything. But it can cause physical and chemical burns, especially in insects and very small vertebrates. So those that are trying to eat on this thing, squirrels or chipmunks or little small animals, they're going to be shot in the face with this acrid liquid, and very, very hot. So you can see that the bombardier beetle is curving its abdomen underneath its thorax and shooting forwards, can also shoot backwards. So it has really great aim with these anal glands. So it can cause problems. Now, other than that, there are some problems that are caused by beetles because they're just so diverse. So we do see a lot of beetles in stored products. If you get into stored products, forensic entomology, you'll be dealing with beetles quite a bit of the time. We won't spend a lot of time during this class talking about those. We'll do mostly medical criminal on this. But if you're interested in that, a simple urban entomology or stored product entomology class will work well. Or, who knows, maybe someday I'll write one for you. Now, so they can cause some problems. They can also cause some inhalation allergies. So we've had people who've had sensitivity to the exuvia of these beetles when they're in foodstuffs. Now, some beetles will reside in dung. So actually this picture that I've been showing you up here on every slide, this is a dung beetle, one of the prettier dung beetles. So it's in Scarabidie. It's a scarab beetle. Notice it's got those little clubbed antennae and very, very pretty. But they go in poop. That's where they live. So, they can act as intermediate hosts for pathogens, along with other beetles that are in various animal dung. So those species that we most commonly encounter in a forensic capacity, though, are those that feed on dead bodies. Those are the saprophagous insects, or the ones that feed on dead tissue. So I will be going over the major families over the next 2 lessons, and we'll talk about those. All right, so that's it for the basic order of beetles. Let me know if you have any questions.